This is an IBM PC clone, but it's not just any PC clone, it's one of the rarest clones to have ever been made because it should not exist. The story of how it came into being and how it ended up here in our shop so we can get it up and going again is a bonkers one. In the early 1970s, two gentlemen by the name of Bud Smith and John Rex Warren decided to start a computer company. You know, as you do. And their first system was released in 1972, and it was the Centurion mini computer. Now, if you've never heard of the Centurion, don't worry, I've got about 60 episodes on this channel talking all about the Centurions that I have here in the room. There's a smaller one behind the camera over there, and then there's this big beast behind me. These are really fascinating systems, and I absolutely adore both the machine and the story of Centurion as a whole. But going back to 1972, when they released that system, it had a CDC-built Hawk drive in it, and it was based around the Eldorado EE200 computer. This combination was pretty formidable because they were going up against machines like the Litton mini computer over here, which was paper tape based. And when you have a random access hard drive compared to a paper tape based system, the performance is going to be on a completely different level. And as a result, Centurion started to get a foothold in the mini computer industry, and they started to grow, building bigger and better and badder systems throughout the years until they became a pretty sizable company. Now, a lot of interesting, weird stuff happened throughout the middle of that. Their entire warehouse caught fire at some point and burned up a bunch of the artwork for the PCBs. That almost bankrupted the company. A lot of things almost bankrupted the company, but they somehow held on and continued to grow. And in 1979, they were pretty sizable and making a really good impression in the mini computer industry. So good, in fact, that none other than Ross Perot took notice of them. And therein is our first clue as to what's going on with this little IBM PC clone here, because it says EDS on the front of it. And Ross Perot is a lot of things, but he also founded and ran EDS. And in 1980, EDS entered into talks with Bud Smith at Centurion to acquire Centurion. And finally, in early 1981, the deal went through and Centurion became a wholly owned subsidiary of EDS. Then they continued to grow. They ultimately got up to around 300 employees. And in 1983, EDS was entering into talks with IBM to acquire a large collection of IBM PCs for use at EDS. But IBM had a price point and EDS had a price point, and they never really seemed to match. So EDS told IBM to, go take a hike, and they came over to Centurion and said, hey, we need you to build an IBM PC competitor. And they came up with this. Now, Centurion thought they were just getting into the IBM PC market, but there was actually an ulterior motive behind the existence of this machine. It was built entirely with off-the-shelf parts, and it was designed to be cheaper than what IBM was putting out. And so Centurion built a handful of these. EDS put some EDS badges on the front, put them on display, and brought the IBM sales guys back over. And they said, look at all these amazing EDS PCs that we have. We're gonna flood the market with these and go into deep, heavy competition with you. Now, EDS was big enough that this actually seemed like a legitimate threat. So IBM caved and agreed to the price point that EDS wanted for the PCs in their office. And once EDS got that price point, they went back to Centurion and shut down the PC building department. So yes, this thing should not exist because it was all just a dog and pony show to get a better deal out of IBM. The total production numbers on these is totally unknown. It could be 100, could be considerably more, could be considerably less. I've never talked to anybody that knows how many of these were actually produced, and I've never even seen any documentation that says these should even exist. So it's an incredibly rare machine, but once it lived out its usefulness, how did it make it all the way to here? And that story is almost as bonkers as why this thing exists in the first place. And it all stems all the way back to around 1984, 1985, when a certain individual named Richard Byron decided to open up a small shop in Dallas called Computer Reset. Now, Byron did a little bit of everything and led an extremely fascinating life, but he also amassed one of the most amazing collections of computer gear throughout the years. And I mean, well, when I say the most amazing collections, I'm talking like a 20,000 square foot warehouse filled floor to ceiling. It was completely out of this world. But unfortunately, in 2018, Mr. Byron suffered an accident and fell ill afterwards. And sadly, he passed in 2019. And this left the fate of the warehouse in limbo. The close friends and family of Mr. Byron knew that they had something special at their fingertips, but getting all of this amazing equipment out into the hands of people was going to be a very difficult and delicate matter. There were a lot of landmines to get by. I mean, first of all, the warehouse was unsafe, so they couldn't just let anybody in. There was a good chance somebody could get hurt or even worse, killed by something falling on top of them. So that had to be very carefully handled, and well, we want to get these things into the hands of hobbyists, so it's very important that we don't let a single person take everything and then try to flip it all for exorbitant prices. But also on top of all of that, there was a ton of really rare special machines that needed to find their way to museums so that the larger audience can enjoy these things. This was an incredibly difficult task, and one that I'm actually glad did not fall to me. That would have been almost impossible to handle without losing my sanity. But a couple of people stepped up and actually took the reins. A good friend of mine, DJ, who was actually a really close friend of Mr. Byron and his family, started working with Mr. Byron's daughter, and they got the ball rolling on this. And DJ had his wits about him and decided that there were a lot of systems in there that would fit very well in computer museums around the country. So he earmarked those for going to either museums or to very special people that needed to get their hands on those systems. And one of the systems that DJ earmarked for that was actually a Centurion. Not this one, but a Centurion minicomputer, very similar to this, but not quite the same, because it was actually a counterfeit Centurion. Now, the story of how the counterfeit system came into being is a pretty wild one, because that's a system that shouldn't exist either. So if you want to know more about it, I've got a whole video dedicated to it. There's a link somewhere around here. But while that was happening, this EDS PC was also hiding out at Computer Reset. Now, this has a much larger problem in that none of the pieces are connected to each other. Everything can be separated very easily, and things can end up in the hands of very different people. Particularly because this has the Centurion logo on it, but the PC down here says EDS. So if you don't know the actual proper full history of this machine, you might think that these two things are completely unrelated. And actually, that's exactly what happened. All of the pieces ended up in the hands of different people. The monitor here on top was picked up by a very kind individual by the name of Marco Rossi. They found it and were fascinated by all of the different buttons and knobs and things on the front. However, Marco was a friend of DJ, and DJ saw it and said, "Wait a minute, I recognize that logo on the front." And after talking with Marco, Marco decided to return the monitor back to DJ so that it could be kept near the other system. Marco, that was incredibly kind of you. And because you did that, we're here today able to get this machine complete and up and going. So thank you so much for that. Now, the EDS PC down here was picked up by somebody completely different, Kevin over at Texelec. Now, if you haven't heard of Texelec, they build and sell all sorts of amazing peripherals for the retro computing community. And well, Kevin is also just a really super nice dude. I give him a call on the occasion just to chat. It's a lot of fun chatting and hanging out with Kevin. But I was over at Kevin's and I really wanted to build a replica of the EDS PC. And I asked him if he'd ever seen a front grille that looked kind of like this for an early PC. And he went, "I have." And he walked out with this. And I was like, oh my God, that's the actual one. And the third and final piece is the keyboard down here. And well, the original keyboard is supposed to have a Centurion logo on it, and it doesn't exist. We never found the person that ended up with that keyboard. But, well, there you go. This machine should not be in this room. And how it got here is unbelievable. And it wouldn't have been possible without the generosity of a lot of very awesome people. DJ, Marco, Kevin, all of you came together to make this machine possible. So does it work? I don't know. I've never plugged it in or powered it on. So that's what we're going to try and get into today. I want to see this machine power up and be a working, functioning Centurion built PC. But I actually have a final goal for this machine. I want it to act as a remote data terminal for the big boy Centurion mini computer back here, which means that we need to get some kind of terminal emulation software running on DOS within it. So that way we can plug the serial cable into the back and load into DOS and then load it up as a terminal and have multi-terminal, multi-user functionality for our big boy Centurion. I think that would be absolutely awesome. But, well, first step is to clean it up because it's a it's a little dirty after all these years. So let's take everything apart, clean it up, see what we can discover about it as we go through it, plug it all back together, turn it on, and see what works. We're going to start with cleaning the monitor up. It's not too terribly dirty, but I think there's a gorgeous gem hiding underneath here. So I'll give it a spray down with some simple green and work the years of grime away. The front will also get some glass cleaner sprayed at it, and already it's looking immensely better. But let's go a little further. I bet this thing is dusty inside too, and I'm curious who actually built it, because even though it says Centurion on the back, I know for a fact they didn't build this in-house. After removing the 2 screws on the side and the 4 screws on the bottom, the entire outer shell lifts right off the top, revealing an interesting monitor inside. All right, there's a lot of really fascinating stuff going on inside of here, but the big burning question was who actually made this monitor? We know Centurion didn't make it, and it was made by RGB Display Corporation. That's a company I've never heard of, but then again, I've never spent much time inside of monitors before. So if you've heard of this company, let me know. But they have a really interesting construction style that we see right here very obviously with this kind of card that's not a card, it's soldered in. And there's 2 more back here, and then there's 3 more on the neck board up here. What a wild construction, but it's horrendously filthy, and I have no idea if it works. So let's blow it off with the air hose at the very least, make sure that it's nice and clean, and then we'll plug it in and see if it at least turns on. It's looking a lot cleaner, but who knows if it actually works, and there's only really one way to find out, and that's to push the button here. But it may not actually display anything when I push the button without being plugged into a computer. So I've got my cell phone set up here with a little spectrometer thing audio. It's just using the microphone to tell me what frequencies are the loudest. And so if it's generating high voltage, we should see a peak somewhere in here. I can't hear those frequencies anymore, so hopefully this will tell us if it's generating high voltage. So here goes nothing. Yeah, look at that. We definitely have a peak up in the upper range here. That is generating high voltage. We have we have a picture of some kind. We've got color set 1 and color set 2 here. These calibrate knobs, horizontal, vertical size, color gain, brightness. Brightness does seem to work. Oh, geez. All right. Before we turn it off, I just noticed that there's a button on here called test. So let's press that and see what happens. Not what I was expecting. It just generates a flat line. Okay. Whoa! It's it's got a built-in test pattern. Apparently it cycles between a flat line or the built-in test pattern, but that's awesome. All right, let's see if we can adjust size and stuff here. The horizontal potentiometer doesn't seem to do anything. Vertical size works though, so that's excellent. Vertical positioning seems to work. We can go over here to color gain. That definitely seems to work. That's like contrast, it seems. And then we've got these 3 color calibrates over here, so we can adjust the color on it so that our color looks exactly like we want. So apparently you knock into test mode here, and then you calibrate your color so that this monitor is totally spot on with whatever color grading that you're doing. And then you pop out a test and you're back to your machine. No clue what the horizontal line is supposed to be here. It doesn't seem to do anything. And it's a shame that our horizontal potentiometer here doesn't do anything. That could potentially not be an issue at all, or that could be a big problem. The only way to know for sure is to plug it into a computer. So let's get the computer up here and work on it next. All right, let's dig into the EDS PC itself. And one interesting side note here before we get too far apart. On the back is the EDS serial number plate, but most importantly, look at the address. 1780 JL Richardson, Texas. If we look at the back of the monitor, same address, 1780 JL. And this one has the Centurion logo. But let's go even further back in time and look at the serial number plate on the full-size Centurion. Warex Computer Corporation, Centurion, and it's all at 1780 JL Richardson, Texas. And this machine was built long before the EDS merger. So there we have it, 100% confirmed. This little EDS PC is indeed a full-fledged Centurion. All right, let's get back to taking it apart and see what's hiding out inside. To get the cover off, there are two little screws neatly marked with cover removal. Once those are removed, the top needs a little tap, tap, tappity tap, and then it slides right off the front. Inside, it is packed completely full. It looks to have all 5 expansion slots filled with various cards, so let's go ahead and get those out. And we'll start at the far end and work our way inwards. And these cards are absolutely massive, filling up the entire length of the case. The final 2 cards are much more reasonably sized though, with the last card being pretty tiny. Next, I want to get the power supply out, as I'm sure it needs a cleaning. There are 2 screws on the side and a lot of screws on the back. I'm not sure how many of these are necessary for removal, but I do know that if I remove all of them, it'll definitely come out. It was fiddly, and the power cable to the motherboard is hilariously short, but eventually I managed to slip it out. Next, let's get the drives out, starting with the hard drive. I'll disconnect all the ribbon cables and get them fully out of the way. Then there are just 2 screws on the side holding the hard drive in place. With those removed, it slides right out the front. The floppy drives are very similar, just 2 screws on the side holding them in place. Then they slide right out the front as well, but they slide out as a pair. Finally, let's get the motherboard out by first disconnecting the serial and parallel cables, which plug directly into the motherboard, which is kind of nice. Then the motherboard just pops off its plastic standoffs and can be rotated and pulled right out of the top, freeing it from its metal cage. All right, I've got everything laid out on the table here, and it's been about 30 years since I've seen inside a PC of this era, but I'm at least gonna try and figure out what's going on. I did take some pictures of the cards and ask around on the Discord, and I think I've figured out some of what's going on, but we'll start with the motherboard here. This is, I think, a fairly standard early PC motherboard. We can see that we have an NEC 8088 right up here, and the socket next to it is empty, so that means that we don't have the math coprocessor, which I believe is an 8087. We have a ROM over here that says Rev 1.9. I'm guessing that's the BIOS. And right next to that, we have a little emblem that says Faraday Electronics. So this is a Faraday-made motherboard. Over here on the left, we've got an absolutely full complement of RAM. I believe that puts this at 256K. Other than that, looking around the board, there's only really one thing that jumps out as kind of bonkers, and that is this chip right down here. This is a 74LS08, and it's had one leg cut and lifted. That is strange, but we're gonna power it up without touching that just to see if it works as it is. I have absolutely no idea what this IC would be used for, so if you recognize what that is or why that leg's been cut, leave a comment below. Up next, we have a pretty bog standard looking floppy controller. Nice big IC right in the center, but other than that, it's a pretty sparse looking card. Notably though, this is also made by Faraday Electronics, the same as the manufacturer of the motherboard. And that makes sense. I'm pretty sure that Centurion tried to source as many components from one place as possible. So I believe that this floppy controller and the motherboard are the original components that Centurion would have put in the system when it was new. Now, a lot of other things have been changed, including the remaining 4 cards that we're going to look at, as well as all of the drives, because originally this machine only had 2 floppy drives in it, and we've got 2 floppy drives and a hard drive in this one. So things have changed, but I believe that this floppy controller is an original piece. And as I said earlier, there are 2 floppy drives and a hard drive in this system now. And this tiny little card is the hard drive controller. It's a Western Digital made, I believe, WD-1004, and looks like maybe -27X. I believe this is an RLL drive controller, which is a fascinating rabbit hole to dive down, the difference between MFM and RLL, and that's something for a future video. But you can see that this is a much newer card, so this was definitely added later because look how few chips there are. So much large-scale integration going on here. Everything is just pretty much consolidated into these large 4 chips here. But this will control that hard drive if the hard drive will actually work. Now we're getting into some interesting cards. This is an STB made RAM expansion card, but you can see so much of it is unpopulated. I believe this would have been also a serial card and maybe a game port, depending on how you spec'd it. But apparently the person that bought this spec'd it out to be just a RAM card. So on the end here we have our full RAM expansion, and that is fully populated. And I believe that'll take the machine up to 684K or something like that. But the rest of this is just the supporting circuitry to get this functioning. And you can see how little it takes. Everything else on here was purely for other functionality. Up next is another STB made card. This is the Graphics Plus 2, I believe. It is our video card, and it's a pretty capable card. I believe it does both CGA and NDA, and it has composite video out the middle here. We can see it's got a nice big IC up here. This is an SY6845R. Then we have a collection of TMS4116 DRAM here, and then things get interesting on this half of the card. And this half of the card is actually why I'm most excited about this particular card. From what little information I can figure out, this pin header on the end is a SASE port or a SCSI port. But it also seems to be configurable as a parallel port. So you flip one of the dip switches up here and it changes whether this is a SASE SCSI port or a parallel port. Why does my graphic card need that? A SASE port or SCSI port is like hard drive type stuff. And there is one advertisement that says you could plug this into a SCSI controller and then use hard drives that way. Why? Why does my graphics card have this capability? I don't know, but I absolutely love it. I have no idea how we can ever put this to use in the future, but we've got to figure out some way to make use of this port on this graphics card. So if you are familiar with this card, or you know what we could use this port for, sound off in the comments because this is awesome. And finally, we have probably the most fascinating yet simultaneously least usable card of the bunch, and that is this one, which is labeled PC3278. This is, I believe, an IBM 3278 terminal emulator card. That would have been the terminal that would have been used for certain IBM systems. The terminals are incredibly rare and very hard to find, so these terminal cards would turn an IBM PC into a terminal that could be used for those. And it's got a full-on N8X305N. This is a microprocessor. This is essentially a computer within a computer. It has its own processor, its own ROM, its own RAM. The whole thing can run almost completely independently of the IBM PC that it's plugged into. I think all it really does is just borrow the bus to use the video card. This is an absolutely fascinating card. I have no idea what I would ever use it for, but who knows? Maybe I'll come across one of the IBM systems that this thing is meant to be used with, and then we'll have a way to actually interface with that system. Now, as I said earlier, this machine would have originally come with 2 floppy drives, and here we have 2 floppy drives, but these are not the drives that would have come in it originally, because those would have been full height drives, and well, these are clearly half height, and they were stacked on top of each other like that. So they could fit 2 of them in one bay. These are made by TEC, T-E-C, which I believe is Tokyo Electronics Company, or Tokyo Electric Company, and they look to be in relatively good shape, so I have no reason to believe that these won't just work. We'll pop a floppy in one of them and see if it boots once we get the machine back together. And finally, the hard drive. This is a half-height Seagate ST238R. This is an RLL certified drive, which means that I believe it comes out to 30 megabytes when used with that RLL controller that we have. Now, the differences between RLL certified drives and MFM certified drives is strange and weird, but I don't have any other RLL certified drives, so I don't know if I have any spares that'll work with this controller if this drive is bad. And talking with Kevin at TechSelect, he said it was unhealthy. So no clue if this drive will actually work, but as long as a floppy drive works, we should be okay, because then we can still boot into DOS and load up our terminal emulation program. I can see why early PCs were such a massive hit. This thing is wonderfully compact, but everything is so modular and easy to handle. Even with just 5 expansion slots, you have all sorts of flexibility in how you want to build your computer out. And when I say it's easy, I mean it. This clip is, of course, sped up, but it really took just under 15 minutes to get everything completely reinstalled and connected back up. Back in the early 1980s, working on these must have felt like a dream compared to a lot of the more complex systems out there. Here we go, first power up. This is pretty exciting. I've got the monitor on, it's showing the test pattern right now, but we'll go ahead and flip that off so it's ready to receive a video signal. I've got everything hooked up except for the hard drive. It is unplugged, so that won't work, and I don't have a keyboard hooked up, so we're just trying to see if it will post. Here goes nothing. Let's flip the switch back here, which is a key, which I absolutely love. Something happened. The power supply has come on. We've got nothing on the screen here. All right, something's broken. Even in this state, this is like minimum viable configuration. I've got just the motherboard, just the power supply, and just this little speaker hooked up. We should be hearing beeps of some kind, but if I flip the switch here, the speaker makes a light little tick, the fan and the power supply spins up, and that's it. Nothing else happens after that. So we could have multiple failures going on here, but well, the only thing to do is to just pull up the troubleshooting guide on -0 degrees and start slowly working through that. I don't have all the tools that somebody who works on these normally should have, like a postcard, so we're gonna try and do as much as we can with what we've got floating around here, and hopefully we can figure out what's going on. For the record, I checked the voltages off camera before I put power into anything, and they checked out totally all right. A clean +5, +12, and -12. But I checked them again here with everything plugged in just to be sure, and yeah, still clean voltages all across the board. So the problem isn't the power supply. And the problem also isn't a shorted tantalum. I mean, aside from the fact that that would pull the voltage rail down, I also measured the resistance from the voltage rails to ground and everything looked good. So following the guide on -0degrees.com, I just slowly worked my way through it until I stumbled across something that was pretty interesting. All right, it might have just been a dip switch setting, or maybe we've got some bad RAM, but all I did was I set the dip switches here to just a base of 64K of RAM only, and suddenly the machine started giving me beeps whenever I turned it on. That's good news. So I put the graphics card back in, I've got it plugged into the monitor here. Let's see if we get something on the monitor. We'll go ahead and turn the switch on. I saw the whole screen flash there. Whoa, we got a blinking cursor. That's like massive definitive progress. That means we're getting somewhere. I still got something hooked up wrong. Maybe we've got some bad memory in it. I don't know, but I got more troubleshooting to do, but that's excellent news. We're getting there. All right, I think we might have some RAM problems, but really the factory BIOS that's in there is just kind of impossible to ascertain anything from. So I pulled out the original BIOS, I've got it right here. I dumped this and I've got the binary file, I'll upload it somewhere. And then I downloaded the super soft diagnostic ROM file off of -0 degrees. I've popped it in, so let's turn the key here and see what happens. We'll pull this out of test mode and power on. Well, there we go. That's something. Supersoft ROM Post Diagnostics versions 1.2. We're getting quite far in there. A lot of things have passed. The 16K critical memory region has passed. Memory refresh passed. That took a long time. I'll snip out the dead air in that one. Oh, there we go. We're doing some video testing. Yeah, that was CGA memory. It passed. Keyboard controller passed. Keyboard scan lines passed. I've got the keyboard plugged in. Well, look at that. We start getting memory errors almost immediately. That was at 1C0, 2C0, 3400. Okay, but that might be beyond the base 64K that we have in there. Man, I don't know. Like, I don't know if we've got something fundamentally wrong or broken on the motherboard, or if we just have the dip switches and everything all set up incorrectly. I'm gonna keep plugging away at this though, and we'll see if we can get there. At this point, with the help of the Supersoft ROM, I'm fairly confident that we have a RAM fault somewhere. But I think we have a deeper issue going on here. Looking through the only documentation that I can find for this motherboard, it looks like jumper J17 controls the base memory size. However, J17 isn't a jumper on my motherboard at all. It's full-on hardwired. I may be misunderstanding something here, but it sure looks like this motherboard was intended to always have 256K on it. So I think what we really need to do here is go through and test all of the RAM chips that are in sockets. And so after removing all 9 bajillion of them, I went through and tested them one by one in my little 4164 RAM tester. I got this thing off eBay and it's absolutely awesome. It's saved my skin multiple times with the big Centurion. My only gripe is that the ZIF sockets are not great. Still, it gets the job done and done well. Well, we definitely had a bad DRAM chip. The little DRAM tester here is showing a red LED. This chip is no good, but we only had one chip that tested bad, although that could be enough to upset it. And I think we're just gonna try and boot it and see if it does anything different. Oh God, that is so long. But we got the blinking cursor now, that's good news. The floppy did do something, and the light on the floppy is on. The floppy is seeking. It looks like it's reading. It's making all sorts of great noises. Whole time we just got a blinking cursor here. Yes! Oh man, apparently the date is January 1st, 1980. My keyboard doesn't seem to work at all, but that is booted into DOS on a floppy that I had that had PC DOS on it. So that is awesome news. I think we can start getting the main case back together and start trying to play with it from there. All right, keyboard time. This particular keyboard was sold as a Cherry mechanical keyboard, so it absolutely should work. But pressing on the keys, I have a sinking feeling that I may have been duped and taken for a bit of a ride here. After removing the screws on the back and getting the top cover off, it's absolutely filthy inside. So let's take this out and give it a quick air shower. After launching who knows how many carcinogens into the Texan atmosphere, let's get it completely apart and figure out what's going on. It was a little sticky, but ultimately it came loose and plonked down with a bit of drama, but oh yeah, that's not mechanical at all. See those dark rectangles? Those look like capacitive pads for a dreaded foam and foil keyboard. Popping a key off further confirms it. I've never seen any mechanical keyboard with key stems that look like this. Well, we might as well get it fully apart to see the deterioration inside firsthand. There's about 20 little screws on the back here, and with all those removed, we can lift the PCB off and big oof.
Not only is this a foam and foil keyboard, the foam and foil pads have a really unique shape. On Keytronic keyboards, these pads are just circular, but here, Cherry elected for this bonkers shape, which makes these really hard to reproduce. Fortunately, I have another keyboard that looks identical, but is produced by Keytronic, which means it uses these circular foam and foil pads. These are much easier to reproduce, and none other than Kevin at TechSelect actually makes new ones. Unfortunately, Kevin is a bit snowed under at the moment, and these are currently on back order. But I think I have just enough to get the job done from previous projects. So I'll go through and peel all the old disintegrated pads out. Then it's a slow and tedious process, but I just go through and clip in all the new pads. They're held in place in 4 separate places, so I usually just slip them into one half, then use a pick to push the other 2 sides in, making sure that I listen for the audible click as they snap into place. With those all in place, I'll give the main PCB a good wipe down with alcohol, and once I'm sure it's properly clean, I'll place the keyboard back on top and screw it down. Now, someone in the past thought it'd be a great idea to cut off the DIN plug on the cable instead of, just unplugging it. So I get the fun job of trying to reverse engineer enough of the pinout to figure out how to solder on a new DIN plug. Between what I could glean with the multimeter and looking at a schematic for a similar keyboard, I was able to figure out which wires were which. Thankfully, the motherboard side of the plug is well known, so it was moderately easy to get a new DIN plug soldered up correctly. And don't worry, this time I remembered to put the plastic sheath on the cable first. The last order of business here is to clean this thing up. The keys are absolutely filthy, and the best way to actually get them clean is just to remove each one. I like to toss all of the keys into a bucket, fill it with warm water and dish soap, then agitate the keys around by hands for a few minutes. Then I remove the keys one by one, give them a wipe down to fully clean and dry them, then pop them back in place. It's tedious and takes a couple of hours, but the results are absolutely worth it. More often than not, the keyboard comes out looking brand new. Plus, it's fun to take a time lapse of it, as it's always therapeutic to watch the keys go back in a completely random order. But once all back in, we gotta take it for a short test drive, and yeah, that feels, well, I mean, it feels as good as a foam and foil keyboard can feel.
All right, all back together, and it looks absolutely stunning. The keyboard should work, but there's really only one way to find out, and that is to turn the whole system on. So we'll come out of test here. I'll reach around over here and flip the key on. Power should be coming up. We should see a blinking cursor, and we should hear a beep. If I didn't break anything. Okay, all right. Oh, that takes so long. Oh man, we have our blinking cursor. Okay, so it should boot off of the floppy disk that I have in this lower drive. So this floppy was actually created for me by a member of the Discord, Howard Poe. And Howard, if you're watching, thank you so much for that. But also, Howard's done so much more than help me with this floppy. He helped me immensely with troubleshooting this beast yesterday. And he's actually just been a ton of fun to just hang out with and talk to. So thanks a lot, man. All right, it should be booting. We should get the date prompt that MS-DOS is gonna give us here. There we go. Current date is Tuesday, 1/1/1980. We don't care what the date is, so we'll just go ahead and hit enter. That worked. It's asking for the new time. We'll just hit enter on that one again. And I believe that the AutoExec bat is written in such a way that it just boots immediately into Procom Plus. Yeah, there we go. Procom Plus, Intuitive Communications, copyright 1987, 1991, Datastorm Technologies Incorporated, unauthorized duplication prohibited. Shh, nobody tell them. Press any key to enter terminal mode. We'll go ahead and hit enter. We've got a nice blue screen here, and it looks like it's pretty much set up for acting as a remote data terminal for the big Centurion. It says add 60 down here. We're in full duplex, 9671, print off online. Let's press a key. Look at that, it echoes back. That's interesting. I don't know if it's supposed to do that. But let's type everything. We'll do THE, quick brown fox jumps over the lazy dog. And yeah, there we go. It looks like everything is working perfectly. That's awesome. All we got to do now is make up a cable to plug this into the multiplexer port of the main Centurion and see if we can get this actually functioning as a terminal. That would be absolutely awesome. All right, I've got the EDS PC in its new place, sitting on top of the second cabinet in our Centurion setup here. I've got the Centurion fully spun up. All 4 drives are visible, all 4 disks are visible. We can see Data6, SoftTerm, FU, DSDD, and Torty. That's all 4 of the disks that are available on the Centurion. I have the EDS PC booted up into Program Plus with a custom cable plugged in. This should work. All we need to do is hit Control-C. Yes! It says CRT1 ready. This is working as a data terminal. All right, let's type .sta to get a status. Yes. Oh, that's so cool. I've never seen the Centurion status display with a blue background. This is absolutely bonkers. Let's push the color set button up here and see how things change. Oh, that's interesting. Now we've got yellow text on a dark blue background. Ugh, I don't like that. I don't like that at all. All right, let's do a .dir1 here. Yeah, there we go. We're looking at the directory listing of of our machine here. How awesome is that? Well, there we have it. One of the rarest IBM PC clones ever made, back up and running and in the land of the living. And it works absolutely amazingly as a data terminal for the big boy Centurion. But there's a few burning questions left. The big one is, did that hard drive work? And the answer is no. I plugged it in, turned it on, and absolutely nothing happened. The hard drive makes a huge amount of clicking. And it just does that over and over and over again and then goes quiet. So that hard drive is unhealthy. I don't know if we can save it. It would be nice if we could, because there might be some Centurion or EDS specific software on there. So that's something that we'll dive into in a future episode. For now, I've got 2 working data terminals for my big boy Centurion. One of them is just this rare, beautiful IBM PC clone that says EDS real big on it. Oh man, I'm so happy. This thing is absolutely excellent. So I want to thank you all so much for watching on this particularly long episode, and I hope to see you next time.